All right, let's go ahead and get started. Also, one thing, I have pushed back the dates for Quiz 5 and Quiz 6 and all that good stuff. So let me show you what I've done so people aren't freaking out. Over here, let me scroll down and actually just sign. All I got to do is just sign in onto the Hawk system here and show you guys what I've done here. Let's see. Number lock is caps. All right, so I took quiz 5, so let me see here. When is quiz 6 due? And because I took it, I made 100 on it. So quiz 5 has been pushed back, and so is quiz 6. Let's see quiz 6. When does the due date for quiz 6 here? And it's scrolling around and due within a week. So it's within a week it's due. I need to go actually to the grade book and stuff, but check out your systems. But it is not due tonight or anything like that. And so, Sal, thank you. September 18th, that's Friday, and I may be pushing that one back too, but not much. We'll see how far we get today. But I just wanted to let you know, and I think quiz 5 is actually due tonight by midnight or 11:30 or something like that. Or is it tomorrow? Okay. I did push that back. See what, 16th? Day 16th? Yeah, it's due on the 17th. I did push it back to give you guys one extra day on quiz 5. And remember, the sections afterwards, you've got, a week or so to get all that stuff done. But you should be working in 2.1. I know there's an A and B part, but that's just to give you guys more questions to do. So there's an A and a B part, and we're finishing up 2.2 today. And I'm going to show you some stuff. I got 2 questions on, it's going to be 2.1. I got 2 questions on 2.1 on absolute values. And then we're going to be moving on into section 2.2, which is those inequalities that people have come by and asked me about and said, well, we haven't gotten there yet. That's why I'm pushing back these due dates and stuff. All right. Last time we were working on absolute value inequalities. Absolute value equalities. If the absolute value of absolute value of x is equal to c, then that means that you can rewrite this without absolute values, either x equals c or x equals negative c. So if I have something like the absolute value of ax plus b equals c, that means dropping the absolute value, ax plus b equals c, or ax plus b equals negative c. Okay? And so, but you had to be careful. Absolute value is always what? Positive. So when you're manipulating these equations, and the Hawk system loves to give you a couple of these problems, and you've got some weird absolute value equal to a negative number, absolute value is positive. It can't be equal to a negative number, so that's when you get there's no solution exists for stuff. Okay? So when you do these problems, you have to have absolute value by himself equal to a number, and then you either drop the absolute values and then drop the absolute value and set it equal to negative that number, and then go and solve. And but remember, with algebra, you have to get the absolute value by himself and then set the 2 equations equal to each other. But what do you do when you have something like this? And I left these 2 problems off last time, and I'm going to show you 2 different ways to do these guys and get solutions. The first one, a little more straightforward. I got the absolute value of 2x minus 1 is equal to the absolute value of x plus 1. I got 2 absolute values equal to each other. That's all right. Treat them, you focus on one absolute value and how you get rid of it. So when I'm going to do something like this, I'm going to drop the absolute value, 2x minus 1 equals x plus 1. I just drop the absolute values and I get my equation. And then I take the exact same equation here, and I drop the absolute value, 2x minus 1, but you got to be, the stuff on the inside of the absolute value could be negative. That could be equal to negative parentheses x plus 1. So you're still doing the same kind of trick with when you drop the absolute value, you set it equal to a positive constant or the negative constant. The constant is the variable inside your absolute value. So you're doing this to it. But now, back to linear equations, how do I solve for x? Solving for x on this equation, I get minus x on both sides. What's 2x minus x? 1x. Minus 1 equals 1. And then I'm going to add 1 to both sides, and I get x equals 2. One answer. And over here, with the negative, I want to distribute the negative. So 2x minus 1 equals negative x minus 1. I'm going to add x to both sides. That's going to give me 3x minus 1 equals negative 1. I'm going to add 1 to both sides, and that gives me 3x is equal to 0. And then I divide by 3 on both sides, and that gives me x equals 0. But the last thing you do on one of these double absolute value equations, absolute value on both sides, is go back and check your answer. Because you do get, sometimes you work it out and you end up basically, by dropping the absolute values, end up giving you an answer that doesn't work. So go back and check it. Let's plug in 2. What's 2 times 2? Minus 1. What's the absolute value of 3? 3, that works. What is 2 plus 1? What's the absolute value of 3? That one checks. Now let's check 0. What is 2 times 0? Minus 1? Absolute value. What's the absolute value of negative 1? Positive 1. What is 0 plus 1? What's the absolute value of 1? This one also checks. So you get 2 solutions on this one. Does that make sense? Question? That is the property of when you do absolute values. To solve an absolute value, you want to get rid of the absolute value by dropping it. But the problem is what's inside the absolute value could have been either positive or negative. So the rule of thumb is when you have the absolute value of something equals a number, constant, to solve this, you set 2 equations. You basically just drop the absolute value, you get x equals c, or you drop the absolute value x and equals, and you put the negative on the other side. So on this one, what I did was, I'm treating this like a constant here, and I got 2x minus 1. I dropped the absolute value equals, and just drop the absolute value here, 2x plus 1. I just dropped the absolute values. But for the second equation, for my or, I dropped the absolute value. I'm focusing on this one. I dropped the absolute value, 2x minus 1, and I set it equal to negative what's inside that absolute value. And that's how I ended up getting the 2 different solutions and stuff, because I'm really doing this positive, negative. But it's a trick on the 2 absolute values to do this. Yes, ma'am?
If one of those answers hadn't worked when you plugged it back in,
Then you walk through it and say that is an extraneous solution. That's our fancy term for no solution. But then there was this other solution that did work. Then there would have been only one answer instead of 2 answers. And that's possible. That one of them works and one of them doesn't work. That's why I always check them. Exactly. Okay? But I'm going to show you guys another way. I made this one actually a little bit harder because I wanted to introduce some technology on you guys. What do I do when they're going to be making this thing all kinds of nasty? Here I got absolute value of 5x minus 4 plus 3 is equal to absolute value of 4 minus x. Well, another way you could do these problems when it comes to these absolute values is basically do something called graph theory on this thing. How do I solve a problem that's nasty in terms of graph theory? What I do is I graph one side of this equation, I graph the other side, and where would the answers lie if I graph 2 sides of the equation? If I graph them, it's the point of intersection. Does that make sense? So this is a little bit of graph theory on this to talk about some of the harder ones. So to do this one, I would do y equals the absolute value of 5x minus 4 plus 3. I'm going to look at the graph of that guy. And I'm going to graph y equals absolute value of 4 minus x. And I'm going to graph this guy. And I'm going to show you this on the calculator. So let me go y equals and completely clear it out because I want to show you where the absolute value button is also located on this calculator. So I'm going to start introducing a little calculator technology with you guys. But this is graph theory. You can always solve an equation by graphing one side, graphing the other, and finding the point of intersection. So where's the absolute value on this thing located at? Well, if you go to math, there's a math button. Let me show you. There's a math button right here, located right below the alpha. I got y equals. I'm going to go to math and slap it over to NUM for numbers. And you see this ABS. What does ABS stand for? Absolute value. And I've got the upgraded operating system on my calculator, so when I hit absolute value, it doesn't put ABS up here, it actually types in the absolute value marks for me. This is one of the things they upgraded on the calculator. If your calculator is newer, if you got an older calculator, it has ABS with a parenthesis. It's the same thing. What you're going to type in here is 5x, whoops, lost that, 5x minus 4, and then go over arrow outside the parentheses. What do I have here? Plus 3. I'm graphing one side. And then I'm going to hit enter, puts it into the calculator. Now I want to graph the other side. But to get the absolute value, I'm going to go back to math, slap it back over to numbers, ABS, absolute value. What is this one? 4 minus x. Does that make sense? And on these calculators, there's a huge difference between minus and negative. This is negative, this is minus. Okay? And I'm going to hit enter. And now I've got both these two guys in my calculator. I'm going to go to a Zoom 6, Zoom standard. That puts a negative 10 by 10, negative 10 by 10 screen on your calculator. Zoom 6. Absolute value graphs make V graphs. How many points of intersection do I have? How many solutions do I have here? Ah, you've been fooled. It looks like from this direction, it looks like 1. But I'm going to zoom in a little bit, right where I think the point of intersection is. So I'm going to take my cursor and go right to the point of intersection. You see it's blinking right on that little V part there. And if I hit enter, it zooms in on that part. And I ask you again, how many points of intersection do you think it is now? The V actually dropped below my line. Now how do I find points of intersection? I think there are 2 of them. So go to calculate, second calculate, and then do intersection. And it's going to ask you a question. Is this your first curve? Yep, and it's using the ABS notation there. Yes, it is. Just hit enter for yes. Is this the second curve? Oh, yes, there's only 2 curves I put into this thing. And then they want me to guess. I'm going to guess the one on the left. So I'm going to take my cursor and go towards the point on the left. I'm going to hit enter, and it zooms in. And what answer does it give me? And remember, you're solving for x. So all you want to give is what x is. What's x equal to in this problem? 0.75. Or 3/4 if for those people who love fractions. And then I'm going to go to second calculate, intersection again. And then I'm going to do the same thing. First curve, yes, enter. Second curve, yes, enter. But then I'm going to take my cursor and take it over to the other side where I think the point of intersection is, and zoom in on that one, and it gives me x is equal to 0.833333, so forth and so on. And if you want to, so the computer, if they want decimals, there you go. If it wants fractions, I take that 0.8333333333, throw a bunch of 3's on there, and go math, convert answer to fraction. Number 1, and what does it give me? 5, 6, and you should recognize 0.75 is 3/4. And this problem actually only has 2 solutions. And the graph method, graph one side, graph the other, actually shows you what only the solutions. It doesn't give you any kind of extraneous solution problems. The no solutions, it just avoids those. Does that make sense? So these more complicated ones like this, you have another alternative. But really what they're really trying to get you guys to do, especially in problems like this, is you set that absolute value equal to the number constant, and then you drop the absolute value and write the equation, and drop the absolute value and set it equal to negative the other side. Yes?
Is graphing problems like we're looking at 70 and like to solve?
No, I mean, you could sit there and put these things on one side and put it on the other, but when they get more complicated, and that's our goal, is to get you guys to have the ability to do more difficult examples. This is the easiest method to do this one. You're right, this is going to be the easiest method is to do the graph. When you get into these really complicated equations, like this example, the easiest method to solve it is graph one side, graph the other, and put it for the point of intersection. So, because that technique always works. Okay? All right, section 2.2. Section 2.2 is about linear inequalities. Okay? Now, linear inequalities. We're talking about, there's three different ways to solve linear inequalities in terms of giving your answer. You can give the number line answer, you can give what we call the inequality style answer, and the set builder, that's a fancy set notation answer here, and you can do interval notation. Honestly, on computers, Hawk system, and on cumulative final exams in terms of the math department stuff, they traditionally like interval notation, but you got to be able to give any kind of answer in the way they wanted you to do it. Now, what it means for 1 to be less than x, which is less than 5, that means all your answers are between 1 and 5, but not including. When you don't include it, you use open circles, okay? And when it comes to interval notation, I use parentheses. Parentheses means do not include. Bracket means include. So if I wanted to include it, this is 1 is less than or equal to x, which is less than or equal to 5. That means I want all the numbers between 1 and 5, but including 1 and including 5. So I put the filled in dots on this guy, which means I'm going to put the equal to there, and it's going to be a bracket. Bracket 1, comma, 5, close bracket. Okay? And the interval notation comes directly off the number line notation. So this one would be 1 is less than x, which is less than or equal to 5. You want to include 5, but not include 1. So you would write it 1 is less than x, which is less than or equal to 5. If I use the set builder notation, which no one ever uses anymore, this little pointy bracket parentheses, x, the little colon means such that, and then you got your answer. 1 is less than x, which is less than or equal to 5, with the closed pointy bracket. That's the fancy way of writing the answer. We're good either way of this one, but the computers want this method. But because you didn't include the 1, it'll be a parenthesis on the 1, comma, 5, bracket, so it means you want to include the 5. Parenthesis means exclude, bracket means include. And this one will be very similar, except the bracket would be on the 1 and open parentheses on the 5. If you've got an arrow that keeps on going, this means it goes to infinity. This means x is greater than 1, because with inequalities we don't write infinity, but in interval notation you do. This will be parenthesis 1, because we did not include 1, comma, infinity. But remember this, you always use parentheses with infinities. If you're going to infinity, it's a number you can never get to, so therefore we always use parentheses for not including infinity, but this is just standard notation. If it's going to the left, you always use a number line from left to right. This will be from negative infinity up to 5, parenthesis on infinities, and parenthesis negative infinity, up to 5, bracket, because we want to include the 5. And if I happen to have two sets of answers, I've got between 1 and 2, and between 3 and 4. So I want the answer to be 1 is less than or equal to x, which is less than 2, or, and it's 3, that one fell off there. 3 is less than x, which is less than 4. I'm going to use the union symbol. It's a upside down, it's a U, but it's a U looking symbol there. It's on your little box thing there, that on your Hawk system. But it's union when you got two sets of answers. So I got parenthesis 1, comma 2, close parenthesis, and then I got another answer, so I hit union, and then I type it in again, 3, comma 4 with parentheses. So bracket means include, equal to, open parenthesis, open circle means exclude, or use round bracket parentheses. Okay. Now, the big deal about all this stuff in terms of inequality is this. You solve inequalities just like you solve equalities, except for one thing. If you multiply or divide by a negative number, what do you have to do? Switch to signs. That's the only rule difference between solving an inequality and solving an equality. Okay? There are different types of inequalities we're going to talk about, you know, the double-sided inequality and things like that, but the rule still stands. When you're solving for x, and you got to either multiply or divide by a negative number, you have to switch to signs. Adding or subtracting doesn't switch any signs at all. So, here we go. And that's basically what I'm talking about up here. So, let's solve this guy. 2x plus 5 is less than 7. How are you going to solve for x? First thing, get x by himself. So, what's your first move? Subtract 5. Adding or subtracting, no sign change. You get 2x is less than 2. Now what do you got to do? Get x by himself. divided by 2. What I do to one side, I do the other. So I get x is less than 2 divided by 2 is 1. Here is the answer in set notation, inequality notation. But how do we want this answer in terms of your inequalities, your interval notation, which is what the Hawk system and the final exam is going to want, multiple choice test and all. If I draw this thing out, here's 0, here's -1, here's 1, here's 2. The answer is 1, but it doesn't have an equal to on it, so it'll be an open circle. And less than, which way do I shade for less than? To the left. And that arrow represents it's going to negative infinity. So the interval notation comes right off the number line. So it'd be parentheses, because you can't include the negative infinity, comma 1, but we don't want to include the 1, so it would be another parenthesis. And that's how you would write it in interval notation. So set notation, a number line notation, and interval notation. But traditionally in math, we like the interval notation, especially the 21st century of computers and math. Yeah?
Since we divided by the 2, why didn't we switch the sign?
Because 2 wasn't negative, it was a positive 2.
So only a multiplying.
Only multiply or divide by a negative number do you switch the sign. Does that make sense? Adding or subtracting, no sign change. How would you solve this one? 3x is greater than 11x minus 16. What would you do? Subtract 11x from both sides. This cancels. What is 3x minus 11x? Negative 8x is greater than negative 16. Adding or subtracting, no sign change. But now, solve for x. What's the last move you got to make to get that x by himself? And something should scream at you besides me. Divide by what number? Negative 8. When you multiply or divide by a negative, you switch the sign. This, you read it from left to right. This is greater than, so when you switch it, it becomes less than. Negative 16 divided by negative 8 is 2. And there's my answer. If I draw this guy out on my number line, this is 2, 1, 0, here's 3. I don't want to include the 2, but it's less than. Show a shade to the left. So what would the answer be in interval notation? Parentheses, negative infinity, comma, 2, because it's open, because it's not equal to, parentheses. Does that make sense? Well, how can they make them nastier? Well, they can throw a bunch of parentheses on this stuff. Let's take a look. Read this problem. Negative 12 is less than negative 2 times x plus 5 plus 2. Now, first thing I would do to solve this thing is distribute the negative 2. That gives me negative 12 is less than negative 2x minus 10 plus 2. Okay? I want to solve for x. So I'm going to combine like terms. Negative 12 is less than negative 2x. Minus 10 plus 2 is minus 8. I'm going to get the x by himself. And honestly, it doesn't matter what side you put that x on. Okay? So I'm going to add 8 to both sides. Negative 12 plus 8 is negative 4, is less than negative 2x. But now, what do I got to do to solve for x? I got to divide by negative 2. And if I multiply or divide by a negative, I got to switch the signs. This is x, and negative 4 divided by negative 2 is a positive 2. But I got to switch the signs. So it was less than, so switching the signs makes it greater than. But here's the deal about inequalities. You can read it like English, or you can read it like Hebrew or Arabic. English, we read it from left to right. So you would read 2 is greater than x. If you want to read it in Arabic or in Hebrew, you read it x is less than 2. You can read it going both ways. Does that make sense? It points down, so you're reading it from right to left. That's a less than. X is less than 2. Reading it the normal right to left way, left to right way, is 2 is greater than x. So remember, you can write it like this, or it's x is less than 2. It's the same thing. If I draw my little number line, mark 2 on the thing, circle it, less than, I'd shade to the left. This is negative infinity, so you would read this as negative infinity, comma 2, parentheses. That would be my interval notation. But remember, you can go either way when it comes to inequalities. Also, I forgot to mention to you guys, Andrew is passing out the roll sheet because we're trying to do assigned seating type stuff, so he's getting everything set up. So he's passing it out, and he wants to do it in blocks because we're gonna identify where you guys are sitting at in the blocks that you sit at and stuff, so pay attention to that. One other thing I want to mention, that was mentioned before, but I want to remind you again, it's on your Moodle site. What happens in here every Friday at 12:30? Review session, where we break open the Hawk system and we actually work the problems on either the quiz or the 2.1, 2.2 sections. We sit here and we do a bunch of problems. It's Andrew sits there and does a bunch of problems for you guys on the computer system, because we know that sometimes this stuff can be frustrating. We're trying to help you out. And you notice I've also been pushing some things back, even though it was due today. I'll give you a few extra days to get it done. I know I want to get you acclimated to get this thing done, because before too long we'll be more along right on dead time when things are due just before class starts, and the pre-section quizzes, and then the post-section is homework that you have to do and stuff. But still, people are having problems in getting the Hawk system down and all the interesting things you got to click on. So I'm trying to be very lenient with you guys. I don't mind pushing some things open again and making sure you get it done. But you can't get it done at the end of the semester. That's not how the math department freaks out about stuff like that. You have to get it done at the time that we're doing it. Just because I didn't get section 2.1 done and it's already closed out on it, will I be able to open up all the homework sets at the end of the semester and you can redo all the problems? No, it doesn't work like that. You got to get them done when they're due now, because the goal is to kind of keep building on this stuff and learn it now, so we can keep adding more and more stuff on to you guys, so we can beat you to death with that cumulative final exam. All right, what about this problem? -4 times x plus 2 is greater than 3x plus 20. Well, first thing I'm going to do is distribute. That's -4x minus 8 is greater than 3x plus 20. I'm going to solve for x, so I'm going to subtract 3x from both sides. That's -4x minus 3x is what? Very good. -7x minus 8 is greater than, that cancels 20. I would add 8 to both sides. So -7x is greater than 28. And then I would divide by what number? -7. Something should scream at you besides me when you divide by a negative. What am I going to do? Switch the signs. So instead of greater than, it's now less than. What's 28 divided by -7? -4. And there's my answer. And let's see if we can do it without drawing the number line. What would this be on interval notation? X is -infinity, comma, -4 what? Parentheses, because it doesn't have equal to on it. X's are less than -4. Now in this next set, this is what they call compound inequalities. The fancy word for compound inequalities that I came up with is two-sided inequalities. When I have the famous two-sided inequalities, read the example. 2 is less than 3x minus 4, which is less than or equal to 19. Well, the big deal about this is you want to solve for x in the middle. What you do to one side, you do to the other. What I do to one side, I do all sides. But here's the deal. All right? You just have two sides to have to deal with it, and same rule goes. The rule is, when I multiply or divide by a negative, I got to switch the signs. Also, remember this. When you write this stuff up, we like the smaller stuff to be on the left. We like the bigger stuff to be on the right. So this kind of mimics what the number line is doing. So let's solve this guy. 2 is less than 3x minus 4, which is less than or equal to 19. You want to solve for x in the middle. What's your first move? Add 4 to both sides. Add 4, add 4, add 4. It cancels in the middle. 2 plus 4 is 6, is less than 3x, which is less than or equal to 19 plus 4 is, thank you, 23. Now what's your next move? Get that x in the middle. Divide by 3. It's positive, so no sign change. So 6 divided by 3 is 2, is less than, this cancels, x, which is less than or equal to 23 thirds. Now, to let you guys know about some of your quizzes and homework set, sometimes, a lot of the times, they want you to put this stuff not in fractions, but they'll say in decimals. So if I put it in decimals, this would be 23 divided by 3, which is 7.6666667, and that's what you would type in. Bunch of sixes and a 7. Okay, they'll give you credit for that. But so watch what the directions are, because I screwed up one quiz one time because I kept trying to do fractions and it wouldn't let me. That's because directions said what they wanted in decimals. Fine. All right. Now I want you to take this guy and write the number line notation for it. So here is 2. Here is 23 over 3, which is that 7.66667. 7.66667. That's your 23/3. But here's the deal. That does not have an equal to on the 2, so that's an open parenthesis. It does have an equal to on the 23/3, which means I want a filled in dot. And X is in the middle. And remember, the interval notation follows the order of the number line notation. So all my stuff is in the middle between these two numbers. It would be parenthesis 2, comma, 23/3, but what? Bracket for the including because of the equal to. This would be interval notation, set notation, number line notation. On this problem here, -9 is less than 3 times x plus 4, which is less or equal to 21. I would distribute the 3. This would be -9 is less than 3x plus 12 is less or equal to 21. What's my first move? Subtract 12 from all sides. -9 minus 12 is -21 is less than, the 12 is canceled there, 3x, which is less than or equal to 21 minus 12 is 9. Now I'm going to divide by 3. It's a positive 3 on all sides, so no sign change. And this cancels. -21 divided by 3 is -7, is less than x, which is less than or equal to 9 divided by 3 is 3. But now, what would this answer be? Because again, the computer 99 times out of 100 wants the interval notation answer. What would the interval be? Parentheses, -7, comma, 3, bracket, right off the interval. Does that make sense? Okay, but now take a look at number 7. -21 is less than or equal to -2/3 x plus 9, which is less than 7. What's your first move? All right, subtract 9. That's fine. Subtract 9. Subtract 9 from all sides. Get that x in the middle. -21 minus 9 is a -30, is less or equal to -2/3 x, which is less than 7 minus 9 is -2. What am I going to do now? I can multiply or divide by -2/3 or multiply by 3 and then divide by -2 or whatever. But let's do what you guys said. You said divide by -2/3. Well, what I do to one side, I do to all sides. That's fine. This cancels. So I get 30 divided by -2/3. But when you divide by a fraction, what are you supposed to do? Multiply by the reciprocal. Flip and multiply. So this would be -3 over 2 times -30. But when you're dividing by a negative number, what should scream at you besides me? Change the sign. So this is less than or equal to becomes greater than or equal to. This is x in the middle, which becomes greater than, switching the signs, -2 times -3 divided by 2. You divide by a fraction, you invert multiply. Let's clean up these numbers. 2 goes into 30 15 times, and 15 times 3 is 45. Negative times negative is a positive. I get a positive 45 is greater than or equal to x, which is greater than 2's cancel, but a -3 makes it a positive 3. But there's a problem with this guy. As I mentioned to you guys before, when you write these double-sided inequalities, these compound inequalities, you always want the smaller number on the left and the bigger number on the right. It's proper form. We've got it the wrong way. I got the big number on left, small number on right. But as I mentioned to you guys before, remember, you can read it like English or you can read it like Hebrew/Arabic, one way or the other. If I read it, 45 is greater than or equal to x, which is greater than 3, I can read it the other way too, and that's the way that it shouldn't be written, which would be, read it this way, what do you got? 3 would now be less than x, which is less than or equal to 45. And that's the proper way of writing the set notation. And the reason for that is because the set notation runs right off the number line, and now I can go for that interval notation, and what would it be? Parentheses 3 comma 45 what? Bracket, because I want that equal to makes it a bracket. Does that make sense? All right, on this next problem here, oh, got fractions, don't care. All right, 1/2, I would distribute the 1/3. 1/2 will be less than, what's 1/3 times 3x? 1x, pretty much x. And this will be minus 1/3 times 4 is 4/3, which is less than or equal to 19/6. Then I'm going to add 4/3 to all sides. This cancels. And this, I would have to use common denominator, but I'm going to go for the, again, trying to get you guys into a little technology here. 1/2 plus 4/3 would give me 11/6 is less than x, which is less than or equal to 19/6 plus 4/3 is 4.5 or 9/2. And again, this would be my answer if they wanted set notation, but traditionally they want interval notation. And if they want an interval notation, it would be parentheses 11/6, comma 9/2 bracket, because of the equal to on that guy. Does that make sense? Questions?
On Hawks, would they want it in decimal form or fraction, or would they tell you?
They would tell you. They would, if they say in fraction form, they would actually specify in fraction form, or if they don't say it all, they'll take it either way. But several of those problems on the Hawk system said decimal form. So if they want it in decimal form, they want this. What was that, 11/6 again? 11/6 was 1.8333333, just write a bunch of threes, comma, 9/2 is what? 4.5 in the bracket. Because, and here's the kind of the trick to let you know, when you try to type in the fraction and it says decimals, it won't let you hit the fraction little button on it. That's how I figured it out. Because I don't read the directions. I figure it out and get it wrong, and then I figure, oh, I gotta go read the directions again. Why? Because I'm a dude. All right, so, look at the next step. We're going from inequalities to absolute inequalities, okay? Now, you have to figure out the type of problem it is. So when you're doing an absolute value inequality, if the absolute value is less than a constant, because you've got this negative positive problem with absolute values, to get rid of the absolute values, the absolute value less than a constant implies that you want to do negative c is less than x, which is less than c. Absolute value less than gives you that compound, quote, double-sided inequality type. But when it is absolute value greater than a constant, then you're going to do it the equal to way. You're going to just drop the absolute value. X is greater than the constant. You'd write it without the absolute value. But when you introduce the negative, and because it's an inequality and you throw in the negative, you've got to switch the sign. So this, you just drop the absolute value. X greater than c, or x is going to be less than, and you throw the negative in there, negative c. So it's basically observation. You've got to figure out what kind of inequality you got right beside the absolute value. So the first thing you got to do is get the absolute value by himself. Well, I did that on this one. I got the absolute value of y plus 1 is less than or equal to 3. The absolute value is by himself, first move. The next thing is, notice the type of inequality. It's less than. Absolute value less than, I want to do a double-sided inequality. Put my constant on the left and make it negative. This means negative 3 would be less than or equal to, use the same type of inequality there. This one has an equal to on it. Drop the absolute value, y plus 1, which is less than or equal to 3. Its absolute value less than tells me to do this method to it. And now you set it up. Now you just got to solve for, in this case, y in the middle. How would you solve for y in the middle of this thing? Subtract 1 from all sides. Minus 1, minus 1, minus 1 gives me minus 4. Negative 4 is less than or equal to y, which is less than or equal to 3 minus 1 is 2. Now there is my answer in set notation. If I wanted it in interval notation, which is traditionally what Hawks and the final exam folks want, how am I going to put it? Because of those equal to, it would be bracket negative 4, comma 2 bracket. And so on Hawks, I got to go first, click on the bracket, and then you go put the numbers in the middle of it. That's how the Hawk system works. But take a look at this guy. I got 5 times the absolute value of q minus 2. Minus 7 is less than or equal to 8. When you're doing absolute value inequalities, the first thing you got to do is got to get the absolute value by himself. So I'm not going to do any kind of double-sided inequality type of whatever. I'm going to get the absolute value by himself first. So what's my first move? What would you do first? I would add 7 first. Get the term with the absolute value with the variable in it by itself. When I do that, this cancels in me. 5 times the absolute value of q minus 2 is less than or equal to 8 plus 7 is 15. What's my next move? Divide by 5. Literally get the absolute value by himself. No constants out front or anything. Absolute value of q minus 2 is less than or equal to 15 divided by 5? 3. Now I stop, pause, and hesitate, and I look at it and ask myself, what kind of inequality do I have right beside my absolute value? Absolute value is what? Less than or equal to. When absolute value is less than, it's the double-sided inequality. So I'm going to rewrite this without absolute values. Negative 3 is less than or equal to, same inequality, q minus 2, which is less than or equal to positive 3. Does that make sense? Now solve for q in the middle. What's my next move? Add 2 to all sides. Negative 3 plus 2 is negative 1, is less than or equal to q, which is less than or equal to 5. There's my answer in set notation. What would it be in interval notation? Bracket, negative 1, comma 5, bracket. That's what they want. Does that make sense? All right. Try the next one. Negative 2 times the absolute value of m minus 1 is greater than 5. Before you do anything, get the absolute value by himself. What's your first move? Divide by both sides by negative 2. And something should scream at you about dividing by negative 2. What do you got to do? So this thing's going to try to mess you up. So this is absolute value of m minus 1 would be now less than negative 5 halves, because I have to flip my sign because I divided by negative 2. Does that make sense? Did I lose you guys anywhere? All right. Remember, pay attention to the problems. What's this problem? What did it turn into? The absolute value of m minus 1 is less than negative 5 halves. Right? Well, I know some of you people would say, okay, that means that negative 5 halves is less than m minus 1, which is less than negative 5 halves, because you're going to do the double-sided inequality. And you screwed it up because you didn't pay attention. Absolute values, keep always in the back of your mind, absolute values must be what kind of numbers? Positive. I don't care what's inside the absolute value. When you take the absolute value of it, it's positive. How can positive be less than a negative number? It's the same trick as what we did when we had absolute values equal to a negative number. You can't have that because absolute values are always positive, right? And I got it less than a negative number. What is my answer? No solution. And my famous terminology, D-N-E, does not exist. You actually can't do this problem. But does that make sense though? Keeps you on your toes. You've got to pay attention to what's left over with this stuff. And if I got absolute value less than a negative number, now listen to me because I want you to make sure you guys understand this. When I got absolute value less than a negative number, what is my answer? No solution. What's the solution if I say the absolute value is greater than a negative number? absolute values are always positive. They're always greater than a negative number. So the answer is going to be all real numbers, negative infinity to infinity. So it depends on the absolute value, so pay attention to that. Yeah.
Why wouldn't you add the 1 to the 2 and the 5?
Because the 1 is still inside the absolute value. So this problem, the first thing you got to do is get the absolute value by itself. So I divided by -2 on both sides to do that. And the resultant is the absolute value of m minus 1 is less than a -5/2. And then officially, I'm supposed to do this stuff, but I caught the mistake. Absolute value can never be less than a negative number.
That's why you didn't set it up like the other ones.
That's why I didn't set it up like the other ones, because that negative with the number, absolute values are always positive. That can't be less than a negative number. That's my answer, is no solution. Basically, I'm done with the problem. Yes, ma'am.
So if it was all real numbers, then
Yeah.
you would put negative.
If the answer is all real numbers, I put negative infinity to infinity. If the answer is no solution, what do we put? What's the symbol for no solution? There is a symbol on Hawks. A circle with a line through it, called the empty set. This is the symbol for no solutions. So on this inequality stuff on Hawks, they're going to want you to put, they won't give you the button for the no solution like they did before. They're going to give you this button. It's on your template on the little keypad. It's at the bottom. That symbol means no solution. Yeah.
Since you were switching, there was, that was like greater than.
Yeah.
Instead of all real numbers, would it just be like 0 to infinity? Because it would be not, like, it wouldn't be big.
No, because you got an absolute value in it. You can even have negative numbers, because when you throw it into the absolute value, it makes it positive anyway. So it really is negative infinity to infinity. All real numbers. Everybody works in that problem. So when you get these weird cases of absolute value either greater than or less than a negative number, either is going to be nothing or it's everything. Let's try this guy. 5 times the absolute value of 2c plus, sorry, do you have a question? I'm sorry, yes ma'am.
Can you have for greater than or equal to?
Yeah.
Would it be no solution or would it be all numbers?
If it was greater than or equal to? Absolute value greater than or equal to a negative number? Well, it's never equal to a negative number, but it's always greater than a negative number. So the answer is all real numbers. All right, so here we go. 5 times the absolute value of 2c plus 7 plus 1 equals greater than or equal to 11. What's my first move? Subtract 1. That gives me 5. Absolute value of 2c plus 7 is greater than or equal to 10. What's my next move? Divide by 5. You have to maneuver the algebra to get the absolute value by himself. Absolute value of 2c plus 7 will be greater than or equal to 2. Now, I got an absolute value, not less than, it's not a double-sided inequality, it's absolute value greater than, so I want to set up my standard 2 equations. My 2 equations are, I'm going to take this equation and just drop the absolute values. It gives me 2c plus 7 is greater than or equal to 2, or it's going to drop the absolute value, 2c plus 7, but if I'm going to introduce the negative, I got to do what? Flip the sign, less than or equal to -2. You always put the negative with the constant, if you can. Does that make sense? Solving for c, I'm going to subtract 7 from all sides. That gives me 2c is greater than or equal to -5. Divide by 2, that gives me c is greater than or equal to -5/2. Or, I'm going to subtract 7 on both sides. That gives me 2c is less than or equal to -9. Divide by 2, that gives me c is less than or equal to -9/2. Now there is the answer in set notation. I want to write the answer in interval notation. Okay? In interval notation, I've got c's greater than -5/2, and I got greater or equal to -5/2, and I got c's less than -9/2. So if I write this guy, because this guy's smaller, I'm going to put him over here. If I write this guy, c is less than or equal to -9/2, what would that be in interval notation? C is less than or equal to -9/2. Less than means parentheses, what? Negative infinity, because you're less than, comma, all the way up to -9/2, but then what? Bracket. And that or means I'm going to hit the union symbol. There's a keypad on that little keypad. Put the union symbol there. Now, C's are greater than or equal to negative 5 halves. So it's negative 5 halves on, so it's going to be a bracket, negative 5 halves, the bracket for equal to, all the way up to infinity. But when you have the infinity, you have to put the parentheses. So you're going to have two sets of answers. Does that make sense? And traditionally, we try to make this work off the number line. That's why I did this one on the left, because that's my negative infinity numbers. That's the left side of the number line. Yes, ma'am.
Yeah, I was gonna ask, does it matter if you put which one, like, which
I think Hawks is going to take it either way, but traditional, you want to make it look like the number line. And so this guy is smaller than this interval. So if you drew it out, you would actually, if you draw out these answers, you get this. You get negative 9 halves here. Here's negative 5 halves. Bracket, and it's this side and this side. And this is your negative infinity to infinity. So negative infinity to negative 9 halves, union, negative 5 halves to infinity. Other questions? All right. Translating inequality phrases. Fancy word for word problems here. All right. Understanding what we say when we say the union of sets. The new set is formed when two sets of numbers are pretty much added. Basically, you put the two sets together. That's what union means. Union means put together. The intersection of two sets, the intersection is formed where the two sets of numbers overlap. In other words, when I want the intersection, and the symbol for intersection is an upside down U, the symbol for union is a U. So the union versus intersection. The intersection of two sets is what the sets have in common. English versus the math word. Intersection means look at these two sets. What are the elements they have in common? Union means take the two sets and just merge them together. Put the two sets together. Okay? So examples. Find the intersection and union of both these two guys. I got this one right here. I've got parentheses 3, 4 bracket. Well, I'm going to draw myself a number line so you guys can see this. Trying to give you a visual representation here. All right. So here is 3. And here is 4. It's open circle on 3, and it's a closed circle on 4, and it's stuff between them. And I'm going to put, I want the intersection and union. All right? So now, I got the other number line, which is from 2 to 8. Open parenthesis, open circle on 2, build in circle on 8, and it's the stuff in the middle here. Be careful. They love to throw trick questions at you on this one, so be careful. So, here we go. What is 3, 4 union to 8? To bracket 2, 8 parentheses. If I, quote, put these two sets together, but if I look at these things, this guy is actually inside the other guy. So when I put them together, what do I get? Just match them together, and together, this goes inside of this, and I still got the big set. The answer is going to be 2, 8 parentheses. Does that make sense? Putting them together, merge them together, and see what's shaded. Everything from 2 to 8 is shaded, including the 2, not including the 8. But, what about this guy? What is 3, 4 bracket intersection of 2, 8? Bracket 2, 8 parentheses. What's the intersection? What do these two sets have in common? What is shaded the same in both these two guys? 3 to 4. This is shaded all 3 and 4, and then some more stuff only between 3 and 4. So the answer here would be parentheses 3, 4 bracket. Intersection, union. Put together versus what do they have in common? What about this set? I got 4 to infinity and 0 to 4. All right? So, number line, here's 4. What would 4 to infinity be? 4 to infinity, open circle on 4, shaded all the way to the right, because the right little arrow represents infinity there. That's talking about that spot. What about this set? 0, 4. Well, here's 0, here's 4. If I bracket, this means filled in dots on these two guys, and I want all the stuff in the middle. So this is bracket 0, 4. What would 4 infinity union bracket 0 to 4 be equal to? If I put these two sets together, merge them together, well, they don't overlap. They actually have basically this putting together with this. What's my answer going to be? Bracket 0 where? Infinity parentheses. Always in parentheses on infinity. This would be my answer. But what would it be if I take open parenthesis 4 to infinity intersection with bracket 0 to 4? What do they have in common? Do they overlap at all? Well, this one doesn't include 0. This does include 0. So they only have 0. I mean, this does include 4. This does not include 4. This does include 4. They don't even have 4 in common. What do they have in common? What's been shaded? What is in common? What is in common between these two sets? Nothing. What is the answer for nothing or does not exist? The no solution symbol. They love symbols with this stuff, so we'll use the 0 with a line through it, located on your little keypad on Hawks. Does that make sense? All right. Okay, so here we go. Express the interval graphically and in interval notation. Okay, so here's the throwing words at you guys now. The word or. The word or means union. The word and means intersection. Or means union, and means intersection. So if I want x is less than -5 or x is greater than +5, I want it graphically. So graphically, or means union. Union means put them together. Well, here is -5 less than, so open parentheses on that, shaded to the left. Right? And then this one is 5, open parentheses, shaded to the right to infinity, greater than 5. There's what the solution is. Union, or means union, or union. I just put my two answers together on the same number line. Now, what is the answer in interval notation? In interval notation, what does that arrow represent? Parentheses, negative infinity, comma, -5. What? Parentheses, union, parentheses, 5 to infinity. Always use parentheses with infinities. That's what the answer is in interval notation. Does that make sense? What about this guy here? X is greater than or equal to 4 and x is less than 3. Well, sometimes if you get in trouble, you want and, you want intersection. When I want intersection, okay, so and means intersection, I want to see what's in common. Sometimes it's best just to draw individual number lines and then grab what's in common. This is the number line for x greater than or equal to -4. So here's -4 equal to, filled in dot, greater than, shade to the right. Here's the inequality for x is less than 3. So I'll draw a number line in order. 3 is about there. Open circle and less than 3. So when I look for intersection, what am I going to get? Intersection means what do they have in common? Look at these two number lines and where they've been shaded at. What do they have in common? They both have -4 filled in. This one doesn't have anything below -4, so it starts at -4, but with the dot, all the way up to 3, but 3 is not filled in here. It's not in common with up here. It's open circle. That's what they have in common. From filled in dot, -4 to open circle 3. In interval notation, that would be bracket -4, comma 3, parentheses. So trying to put the English with the symbolism here. Union, just put the two answers together on the same number line. Intersection, draw the two number lines and see what's been shaded at the same time, what they have in common. And then from that, draw your interval notation. All right. Word problems. Let's take a look at this guy. When deep sea fishing, the optimal depth D in feet for catching a certain type of fish satisfies the inequality 28 times the absolute value of D minus 350, close absolute value, minus 1400, less than 0. Find the range in depth that offers the best fishing. In other words, what are you supposed to do? Solve for D. If I was going to solve for D on this thing, what's your first move? I would add 1400 to both sides. This would give me 28 times absolute value of D minus 350, close parentheses, is strictly less than 0 plus 1400 is 1400. What's your next move? Get the absolute value by himself. So I'm going to divide by 28. This cancels. Absolute value of D minus 350, close absolute value, is less than 1400 divided by 28. 50. Does that make sense? Now, pause, hesitate, and ask yourself, what type of inequality is this guy? Is it going to be a 2 inequality, or is it going to be the famous one big inequality, double-sided inequality? Is this compound, or is this going to be the union of 2 inequalities? This is less than. Absolute value less than. How do we solve absolute value less than? Just to remind you the formula. Absolute value of x is less than c implies you do the double-sided inequality. Negative c is less than x, which is less than c. So this would turn into what? Negative 50 is less than, drop the absolute value, d minus 350, which is less than positive 50. You have to rewrite the equation without absolute values. We've got 3 different forms for this. Absolute value equals a number. You say x equals number and x equals negative number. You got absolute value of x is greater than a number. You say x greater than number or x less than negative number. And if you got absolute value of x less than number, you say negative number is less than x, which is less than number. 3 different methods. This is the less than, so you do the double-sided inequality. How do I solve for D? I solve for D in the middle. So what's my last move? Add 350 to all sides, which tells me that negative 50 plus 350 is 300, is less than D, which is less than 50 plus 350 is 400. So in interval notation, that would be parentheses 300, comma, 400, because D is in the middle between these two. In other words, in English, I would be looking between, for this deep sea fishing, depths between 300 and 400 feet. Does that make sense? Okay? Well, I'll tell you what. You guys have had such interesting issues with some of this stuff. I was going to go on into section 2.3, which I should, but I just wanted to do one of the little Hawks things for you guys. So let's see if I can find one to do. Stay logged in. All right, so here we go. I'm not going to do the whole set, but is there one of these things that you would like to see me do? Well, quiz 5 is not up here because I made 100 on it. How about quiz 6? Quiz 5 should already been done. All right, so quiz 6. Come on, it's working on it. Quiz 6. You want me to start it? All right. This is doing the quadratic stuff. Okay, so quiz 6, I'm going to push this stuff back to next week because this is on, quiz 6 is on section 2.3 stuff. So I'll make this thing due on Monday. I'll push it back a couple more days because I'm just going to get introduced. Remember, these quizzes are supposed to be pre-section quizzes. But here's the deal. How do I solve y squared minus 10y plus 16 equals 0? Now, this is the whole idea behind solving inequalities here. So let me move this thing down. All right, there it is. Y squared minus 10y plus 16. Okay? So, y squared minus 10y plus 16 equals 0. We're back to doing inequalities. But it's a quadratic. So what do you want to do with quadratics? You want to set them equal to 0, and if you can, you want to factor them. So this is working on your factoring skills once again. How does y squared minus 10y plus 16 factor? What times what is 16 that adds up to be 10? 8 and 2. So it's y, 8 and 2. Now, with a plus, they got to have the same sign, but since the middle term is negative, what sign are they both going to get? Negatives. Now, with quadratics equal to 0, you want to factor the quadratic and then set each factor equal to 0. Because if two things multiply together equal 0, either the first dude's equal to 0 or the second dude's equal to 0. So solving for y equals 8 and y equals 2. Add 8 to both sides, add 2 to both sides. So on this particular problem, I get y equals 8 or y equals 2. And then I go on to the next problem. Okay? And another inequality here, I've got negative, 7x squared plus 8x equals 2. Right? And so I just want to show you something or other before I actually do this problem. This is my second problem here. Now, personally, it doesn't matter because they say use the quadratic formula, and we'll talk about that in a second. But when I'm solving a quadratic, the first thing you must always do is set it equal to 0. Now, I got two different ways I can set this thing equal to 0. I can pull the 2 to the left and subtract 2 from both sides, or I can take the negative 7x squared plus 8x and move that part to the right. Which way would I prefer doing? Which way do I like doing? I like making everything positive, especially the leading coefficient. I want to be positive. I want that coefficient in front of that x squared factors better. If it's going to factor, you want him to be positive. Does that make sense? So I always pull this stuff to the side that makes the x squared positive. So I would add 7x squared to both sides and subtract 8x from both sides. This thing completely cancels on the left, so I got 0 equals 7x squared minus 8x plus 2. So that's what section 2.3 is all about. We're talking about quadratics, okay? So, well, if I got ax squared plus bx plus c equals 0, where a is not equal to 0, this is called a quadratic equation in terms of one variable. We're not doing any of that multivariable stuff. This is just one variable. The degree is 2 because it's the largest exponent of that single variable. Now, here's the deal. The goal here is, if you want to solve this guy, you want to factor it. Because when you turn things into factoring, you have the 0 factor property. If a times b equals 0, that means either a equals 0 or b equals 0. So when you got these quadratics, like for example, I got x squared minus 9x equals 0. Solve for x. First thing you want to do is you want to factor it. So I wanted to factor out the x. What am I left with? Well, it's only two terms, so I can only factor out what they have in common. X minus what? 9 equals 0. You set each factor that has an x in it equals 0. So this is a factor, and x minus 9 is a factor. So you set x equal to 0, and x minus 9 equals 0. Well, x equals 0 is one of my answers. And the other one, I want to just solve for x, so I'm going to add 9 to both sides. That gives me x equals 9. I get two solutions when it comes to these quadratics. Sometimes, well, the fact is, I can either get two solutions. Sometimes I can get one solution. Sometimes I can get no solutions at all. Sometimes these guys just don't solve. So here's this next guy. I got x squared minus 3x minus 10 equals 0. I've already set the quadratic equal to 0. So I want to factor it. How does x squared minus 3x minus 10, how does it factor? X squared is x and x. What times what is 10? That subtracts up to be 3. 5 and 2, and because it's a minus, one's negative, one's positive, opposite signs. Since the middle term is negative, I want the bigger number to be negative. That'll be negative 5 and plus 2. Then I set each factor equal to 0. So I get x minus 5 equals 0, and x plus 2 equals 0. I'm going to add 5 to both sides on the first term. I get x equals 5. That's one solution. Or the next solution, I'm going to subtract 2 from both sides. I get x equals negative 2. Two solutions. All right, look at the third one. They tried to mess you up here. I got 6x squared minus 8x minus 8. However, when it comes to this stuff, always, if you can pull out anything that's in common, yank it out before you start doing this anti-foil factoring stuff here. 6x squared minus 8x minus 8 equals 0. What can you got in common? I can factor out a 2. 2 times, that would be 3x squared minus 4x minus 4 equal to 0. 2 is a constant, leave it alone. Now I'm going to try to factor this guy. But this is the tougher of the factoring. I got 3x squared. The factors of 3x squared are pretty much just 3x and x. The factors of 4, inside the parentheses here, is just 4 and 1 or 2 and 2. But because it's a minus, I have to figure out what I get to the middle term. I want to subtract up to get the middle term. So I'm going to do, to get a 4x, I'm going to do 3x times 2, that gives me 6x. And x times 2, that's 2x. 6x and 2x has a difference of 4x. So I'm going to use 3x and x, and 2 and 2 seem to be the factor that works. 2 and 2, but watch your signs. I want the bigger one to be negative, but the 3x times a 2 is going to give me the bigger number, so I want that 2 to be negative and this to be positive. And so when I fold it out to double check myself, 3x squared, 3x times 2 is negative 6x, 2 times x is 2x, negative 6x plus 2x is negative 4x, and 2 times negative 2 is negative 4. So I fold it out to double check myself. But here's the deal. The goal is to solve for x. Get x by himself. So set each factor that has an x in it equal to 0. What happened to the 2? Nothing. It was factored out, but there's no x on the 2. Only set the factors that have x in it equal to 0 so you can solve. I would subtract 2 from both sides. That gives me 3x equals negative 2. Divide by 3, x equals negative 2/3. Or add 2 to both sides, and I get x equals positive 2. So I get 2 solutions on this. The first thing about quadratics is you want to, quote, factor them if possible. If it doesn't factor, well, we have other techniques. Complete the square, and we have the famous quadratic formula, which I know you guys all played with before. Yes, sir? Well, it's just a factor, but remember, I'm solving for x. Because I factored just a constant, nothing happened to 2. It's just a constant out there. It's still out there, but when I'm solving, I set each factor that has x in it, because the goal is to solve for x. Just completely ignore it because it doesn't have an x in it. Study this stuff, and I'll see you guys next time.